Okay, so this is our third video on hyperbolas, and I was just going to go over briefly this other way of finding the asymptotes, a third way of finding the asymptotes. And then on the next page, I'll do an example of graphing a specific hyperbola, and I'll find the asymptotes two different ways, and one of them will be this way. So you can see its application with actual numbers. Okay, so I'm using center 0, 0. We're just doing that so you get a feel for this, before you maybe take pre-calc and it looks a little more complicated. Because people get thrown off by these hyperbolas if you try to do everything at once. So the center is 0, 0, and this is one of type 1s. It has the horizontal, the vertices are in a horizontal line with the center, right? And you would go A, whatever A is, to the right of the center, and A to the left. And then you draw a little box. Don't worry so much about the equation at this point. Just assume that you know the stuff from the equation from the previous page. The main thing is I actually drew the B's in. These points here are not points on the graph. If with an ellipse, they would be. You draw your ellipse like this, right? But in this case, for hyperbolas, they're not on the graph at all. But if you form a rectangle with those, like this, it turns out very nicely that the asymptotes go right through the corners. Okay, so if you were supposed to graph it, you could do that. Now, if you're supposed to find the equations of those lines, graph it, and then find the equation for the line. It goes through the origin, so it's going to be y equals mx, because the y-intercept is 0. It's usually mx plus b, but b is 0, right? So y equals mx. What is m? Rise over run. So the rise here, if you go from the center, you're going up b, and then you're going over a. So rise over run is b over a. You can just see it right there on the picture. So this is kind of a nice way to remember. So you don't, because what's going to happen is sometimes you're going to get it upside down if you're just guessing. You're going to, or maybe just trying to remember and you don't have a way to, if you don't have a trick to remember, you're going to get it upside down sometimes. B over a instead of a over b, or vice versa, depending on which one's correct. Okay, the type 2 one, still center at the origin. Right? Now the B's are left and right, which means those are not the vertices. Remember, for hyperbolas, the vertices are always the A. Okay, so those are the vertical vertices. Draw a little box. Asymptotes goes through the corner. See? It works the same with both. The only difference is when you look at this one, and you do the rise over run, you notice the rise is A and the run is B. So it's A over B. This was B over A. But you see, you don't even pay attention to that because these are going to be actually numbers. Say that's a 5 and that's a 2. Plus or minus 5, plus or minus 2. Well, this is going to be 5 halves. If this is 5 and that's a 2, it's going to be 5 halves, If this is a 2 and that's 5, it's going to be 2/5. You just read off whatever numbers are there. You're not really worried about whether you're calling it A or B or not, right? It's just rise over run. So that's another way to do it. And I'll do the second time on the next example. I'll do it this way.